This short video introduces the latest stage of design for a large displacement vessel Barrier for the Singapore Cruise Centre. The aim is to prevent a 335-metre cruise ship penetrating far into the harbour. The vessel has 72,000 tonnes displacement with 77,000 tonnes mass, including the added mass. We've taken an initial velocity of 6 knots. The vessel stopped within 90 metres after contacting the barrier. The bow is stopped 45 metres from the cable car line. Kinetic energy is changed to potential energy and stored in the proprietary TED structures. The maximum barrier tension reaches 800 tonnes. All the time, 23-metre wide side entrance is available and open to ferry traffic. It's an elegant and robust structural design. It's analysed with rigorous engineering, time domain simulation, and a full understanding of the physics of the problem. We're going to see some dynamic simulations. This is a static snapshot. The 3 pictures on the left are different views of the ship entering the harbour, and the harbour is simulated with objects in the program Orcaflex, the cable car run, the Sentosa Tower on the north side of the island is over here. The hotel station is over here. The new structures are shown. Here's one with a blue stripe along the top, one of the TED structures, the other one on the other side of the harbour. And in plan view you can see this one's aligned with this pier, and this one's aligned with the other side of the harbour and allows space for vessels to pass through here. That's a 23-metre wide gap. We will see how the velocity of the ship changes from 3 meters per second down to less than 0. That's 6 knots is 3 meters per second, so that's velocity of the blue curve. The barrier will be seen deflecting, and this is the extension of the barrier in a center point. Each of these squares is 20 meters of deflection. Then the barrier tension will be seen rising up to a maximum of less than 8,000 kilonewtons, which is 800 tons. Now we're going to see this simulation replaying faster than real time. I'll check the speed. I think we're going, yes, 500% faster, or 5 times real time. Plan view, as we saw in the previous slide, and the ship at this point has been stopped by the barrier, the blue barrier. This is the beginning of the simulation. The ship's travelling into the barrier uncontrolled at 6 knots. It starts to touch and deflect the barrier. We see the ship velocity decrease, the barrier deflection, and the barrier tension increase. In the bottom slide we can see the ship now travelling very slowly backwards and rotating in yaw a little. It would in fact touch the sides, but these are robust structures and they can tolerate that kind of minor impact from this ship. The cable car run is seen overhead, and in this plan view at maximum, the minimum distance the bow got towards the cable was 45 meters. The turning circle is this blue line here. We've kept the structure just outside the turning circle. Since these structures were shown last to DCNS, they've been narrowed down and lengthened. And there's no need ever to disconnect the barrier as far as we can see. There's always this gap open for ferry vessels, and the barrier can be disconnected whenever required, but with that gap open all the time, it may be unnecessary to frequently disconnect the barrier. That's the end of this presentation. The main points were that the ship is stopped within 90 meters after contacting the barrier, more than 45 meters from the cable car line, maximum barrier tension 800 tons, a 23 meter side entrance, always open to ferry traffic, and we stay outside the turning circle.